Hello everyone, welcome back to chapter 3. In this video, we are going to talk about chapter 3.3 electrolytic cell part 2. So we start off with the uses of electrolysis. Electrolysis can be used for electrorefining and electroplating. For electrorefining, it's used to purify an impure metal in which the impure metal we put it as the anode and the pure metal we put it as the cathode. And for electroplating, this is the setting up of an electroplating system. So the subject to be plated is connected as the cathode, and the metal we want to use as the coating layer, we put it as the anode. So the anode, the copper dissolve and then it will coat up and plate onto the object we wanted. Electroplating is used for decorative purposes or to protect a metal from corrosion. So for the electrolysis process or in an electrolytic cell, we're going to apply Faraday's law to perform calculation. So Faraday's law describes that the amount of substance produced at each electrode is directly proportional to the quantity of electrical charge Q that flows through the cell. In short, we can say that the amount of substance which represented by the mass is directly proportional to Q. So Q is the electrical charge, in which you have the formula Q equals to IT. Q refers to the charge with a unit coulomb, capital letter C. R refers to the current with a unit ampere, capital letter A. And T refers to time with the unit second. So electrical charge refers to the amount of currents that flows through the cell for a certain duration. For Faraday's law, we have a Faraday's constant with a capital letter F. So it has a value 96,500 coulomb. So it is the same as the electrical charge. But for this Faraday's constant, it has a relationship with the mole of electrons we have for a half equation. So say if you got one mole of electron, is either accepting or donating electron is equivalent to 1 Faraday constant. Or if you have 2 moles of electrons, it equivalent to 2 Faraday and so on. To perform a calculations for an electrolysis process, we want to apply Faraday's law. So here is a few guidelines for you. They classify into 2 categories. So first, if you want to find mass or volume of a product, okay, it's either at anode side or cathode side. We want to find the mass or volume. So first of all, identify what is your target half equation. Is it anode or cathode? Is it oxidation or reduction? So you need to show one half equation. Second, to calculate the amount of charge using Q equals to IT, then using Faraday's law, find the mole of our target product from stoichiometry ratio. And then lastly, to find the mass or volume of our target product. Okay, so this one is to find the mass or volume of product. But we can also use this Faraday's law to find the charge, current, or time. So still the same, we need to find out what is your target half equation. Is it anode or cathode? So what is the half equation? Then you need to find the number of mole from this half equation. Next, using Faraday's law, okay, using stoichiometry ratio, find the amount of electrical charge Q. Then using the formula Q equals to IT, either you want to find the Q, you want to find the I, or time. Alright, so let's look at our example questions number 1. Says that in the questions, an aqueous solution of copper sulfide is electrolyzed using a current of 0.150 ampere for 5 hours. So in this case, we know we have an aqueous solution copper sulfate. So over here, you have your Cu2 plus and SO4 minus and also H2O. And you have the current, which refers to a symbol I, 5 hours, which is the time in which you need to convert into second. So the questions ask you to calculate the mass of copper deposited at cathode. So in the questions have already given you the cathode. So you need to write the target half equations at cathode. Okay, we need to find the mass. Of course, you need to know about the mole of copper deposited. So first of all, your half equation. So remember to write out the terminal. You must write out the terminal, even if you got a correct equation, but without terminal, you won't get this mark. Okay, so at cathode, Cu2 plus undergoes reductions to produce Cu. So this is our target. So actually, you can identify from the clue here. Okay, the clue is the one that you want to find, copper, therefore Cu2 plus. Okay, into Cu. So first of all, calculate the Q. Since we have already got the ampere, we got the current and the time. Current is 0.150 and the time you need to convert into seconds. So 5 hours, 60 minutes, 60 seconds, and you get 2,700 coulomb of charge. Next, we want to use the Faraday's constant and stoichiometry to find what is the mole of our copper. Okay, so remember that Faraday's law says that if you got 1 mole of electrons, it equivalents to 1 Faraday's value. So now, if I want to produce 1 mole of copper, so refers to our half equations, 1 mole of copper, I need to accept 2 mole of electron. So 2 mole of electrons equivalents to 2 Faraday's value. Therefore, to find the mole of copper is equivalent to the amount of charge, okay, using the current and the time given in the questions. And then we do our cross multiplication to find the number of mole of copper. So for this Faraday constant, is equivalent to 96,500 coulomb. Okay, and then you do your cross multiplications. 1 mole of copper multiplied with 2,700 equals to the x mole, the unknown number of mole, times with 2F. So eventually you will get your number of mole of copper equals to 0.014 mole. So by doing cross multiplication. Lastly, to find the mass of copper using the mole times with the mass of copper, you will get 0.86 gram. For example, questions number 2, an aqueous solution of silver nitrate is electrolyzed using in an electrode by passing an electric current of 2.0 ampere. So we have current over here for 90 minutes. Remember that the time you need to convert into second. So A, what mass of silver deposited at cathode? So over here giving you the clue, we need to find the number of mole for silver and it occur at cathode, so reductions reaction. So first of all, the target half equation occur at cathode. So Ag plus accepting 1 mole of electrons to form 1 mole of silver solid. So since the current and the time is given, that we can calculate for the Q. So Q equals to IT equals to 10800 coulomb. Don't forget about the unit for charge. Then after that, we need to make stoichiometry to apply this Faraday's law. All right, to form 1 mole of silver, according to this half equation, to form 1 mole of silver solid, it need to accept 1 mole of electron. So 1 mole of electrons equivalents to 1F. So 1 mole of silver, 1F. To figure out the number of mole for silver is equivalent to the charge that passing through it. Okay, so this is similar like the amount of charge passing through the electrolytic cell. Okay, this amount of silver will be deposited and this one is a standard one. Okay, so we do the cross multiplications to figure out the mole of silver. Okay, so cross multiplications, 10800 divided by the Faraday constant, and the number of mole of silver is 0.112 mole. So to find the mass of silver, just multiply with the atomic mass, and it is equals to 12.08 gram. Alright, and for second questions, part B, calculate the volume of the gas at STP. STP stands for standard temperature and pressure liberated at anode. Okay, so if you look at the solutions Ag plus and then we got Na3O and then H2O. So anion is attracted towards anode. So we have this NO3 minus and H2O. So we know that NO3 minus, this is also anion. We are not going to choose this one. So definitely we are going to discharge this H2O. So the clue of these questions is it occur at anode. So we know that oxidations happens at anode. Okay, and then you need to identify what is this gas. As just now we said, we will choose to discharge H2O at anode. So oxidations of water, okay, will produce oxygen gas. So our target half equations go this way. So at anode, water will oxidize, that means release electrons to produce oxygen gas. So you can see in the half equations here, 1 mole of oxygen is equivalent to 4 mole of electrons. Using the current and the time given, we're still having the same amount of charge, which is 10800, which calculated earlier in part A. So using this value, we are going to do stoichiometry. Okay, to form 1 mole of O2, according to the half equation, it will release 4 mole of electron. So this equivalents to 4 Faraday constant. So doing your cross multiplications to figure out mole of oxygen gas for this amount of charge and number of mole of oxygen equals to 0.028 mole. So to find the volume of the gas as STP, remember that STP, it means that it happened at 0 degrees Celsius, it happens at 1 atm, and the volume is 22.4 liter per mole. Okay, so for 1 mole, it occupied 22.4 liter. Now we only have 0.028 mole. So volume of oxygen, 0.028 multiplied 22.4 mole, liter per mole. So it gives you 0.63 liter. Alright, so our last example is questions number 3. A technician is planting a faucet with 0.86 gram of chromium. So you are given the mass of chromium in which you can find the number of mole of chromium. Okay, from an electrolytic bath containing Cr2SO43. So chromium sulfate aqueous solution. So over here we can see oxidation state of our chromium, which is Cr3+, and the sulfate ion is SO42-. So given the time over here, 2.5 minutes, remember time we need to convert into second. And this time is allowed for the planting. Determine the current needed. You need to figure out the I. So for these questions, we need to follow the second guideline. Okay, in which you need to figure out the number of mole of chromium, figure out the number of mole of electrons, which then you're using stoichiometry to calculate the Q. So once Q is calculated from the stoichiometry, you can then calculate this current needed. So the first steps over here is still to find the target half equation. Okay, so the clues over here is from the mass of chromium. So if you realize that the mass of chromium is given, it means that the solid chromium is deposited at cathode. So the target half equations is at cathode. So Cr3 plus aqueous solutions plus 3 mole of electrons to get 1 mole of solid chromium. So, but now this time we cannot find the Q because there's an unknown current. Using the mass given, we figure out the number of mole of chromium. So 0.86 divided by the atomic mass of chromium, 52, to get the number of mole is 0.01654 mole. So using stoichiometry, we know that for 1 mole of chromium formed, it required 3 moles of electrons. So according to these half equations, so 3 mole of electrons equivalent to 3 Faraday constants. So doing your cross multiplications, if you produce 0.01654 mole of copper, what is the charge needed? Okay, so this charge refers to your Q. Okay, so we do the cross multiplications to find what is the value of Q. So once you got this Q value, apply Q equals to IT, and the answer for current equals to 31.92 ampere. Alright, that's the end of chapter 3.3. Please attend the exercises 3.3. So I'll see you in the next video. Thank you.